NCCER, Welding Level 3, Module 6, Shield Metal Arc Welding, Stainless Steel Groove Welds. Objectives, you can pause your screen if you want and read through your objectives. Performance tasks, you can pause your screen if you'd like and read through your performance tasks. All right, let's talk about carbide precipitation and what is going on in this. With stainless steel, you run the risk of sugaring. You also run the risk of welding it too hot and turning that pipe black. And it's going to sort of burn out the stainless in it, if you will, ruin the stainless steel. Yeah, if you're on a weld test and you turn the pipe black, you can go ahead and start packing your bucket up. Interpass temperature should be controlled to prevent carbide precipitation while welding austenitic stainless steel. What does it mean controlling the interpass temperature? That means you're not going to try to get this too hot. You want to take your time on your stainless. So don't try to set any speed records. Welding stainless, you're going to pour too much heat into that pipe and cause that carbide precipitation to build. Again, then breaking down that stainless corrosion resistant impact that we've got with stainless, and you're going to ruin it. You're going to ruin it. Carbon content increases carbide precipitation in stainless steel. So the more carbon we have in that stainless steel, the more likely that carbide precipitation is to happen. Carbon content below 0.03 decreases carbide precipitation in stainless steel filler metals. Now that 0.03, just to give you some perspective, the carbon content in your A36 mild carbon steel is 0.30, right? You're below 0.30. This is a tenth of that. So that's pretty low as far as the carbon content in this to help prevent some of that carbide precipitation. You want to maintain a short arc when welding stainless steel to limit atmospheric contamination, which causes porosity. And this is the same for 7018 even. And again, it's more so with your stainless steel rods. But you know this, you understand this when you're on that overhead 7018 and you're trying to drag onto your plate and your long arc a little bit too much and you blow porosity in all your starts. That problem is going to magnify greatly when you hit these stainless steel stick rods. They are prone to that porosity. Carbon content dictates heating requirements in Martinistic stainless steels. And that's not just common of Martinistic. Carbon content dictates heating requirements in all steels. That's where we get back those ASTM numbers. A36, we mentioned, doesn't have to have preheat. Unless it's freezing outside, that metal is below 32 degrees, then we have to bring it up to 70 degrees ambient temperature before we can weld on it. But carbon content tells us when we have to preheat, maintain interpass, and post-heat treatment. Prevent hydrogen cracking after welding Martinistic stainless steel by cooling slowly in air. So what happens? In the heat-affected zone, hydrogen diffuses. It finds its way into, it's pulled out of the air. It gets into your weld pool and hangs out. Now, if you cool it quickly, that hydrogen is going to escape. It has to get back out to the atmosphere as this cools, okay? If you cool it slowly, the hydrogen has time, so it doesn't come out of your weld forcefully. But if it cools quickly, it's going to crack. You're going to get hydrogen cracking, underbead cracking caused by that. Stainless steel rods, E is going to be for the electrode, and then you're going to have some numbers that basically you have to look up, so it doesn't read as easily as it does on the carbon side. So 316, 308, 309, you're going to look those up and see what the uses are for those rods. Now the suffixes in the end, that's where you're getting this -15 at. You have a -15, which is a usability designation. This is the -15 specifically has a lime coating, which is resistant to moisture, thus producing less porosity. So that lime pulls moisture out. So it's essentially acting as a barrier, helping you to keep the porosity out of your weld by limiting the amount of hydrogen, the moisture that gets sucked into the flux coating on these welds. So you see the -15, you know it's a lime coating. Electrodes should be stored in rod ovens between 2 and 250. after they have been removed from their sealed container. So you pop the top on those and then find an oven. And 250 is where we keep ours, according to the American Welding Society and their accredited testing facility stipulations. Our rod ovens are kept at 250 degrees for all your low-high and your stainless stick rod needs. After removed from the oven, stainless stick rods should only be out for 4 hours. And if you'll recall back in our stick electrode section, this is called exposure time. Exposure time is the amount of time that electrode can be out of the oven and in the regular atmosphere. So other than that, it should be at 250 degrees. If you're going to be welding longer than 4 hours, you're going to make a second trip down to the tool room or get a portable rod oven, which plugs into 110 and keeps you at the 250 that you need. Again, we talked about how the electrodes really don't make sense. Like this 3 doesn't mean 3,000 pounds per square inch. It doesn't mean 30. It doesn't mean 307. Basically, you look up the number for the intended use. So 308, most often used to weld base metal of similar composition as AISI types 301, 302, 304, 305. 309, these electrodes commonly used for welding similar alloys in wrought or cast form. They're used for welding dissimilar metals, such as joining type 304 to carbon steel, welding the clad side. So this is a stainless to carbon rod. And these two, typically, your 308 can be welded stainless to carbon as well. Or at least we're welding on some of our WPSs, and it's passing a bend test. So we've proved that it can. But you're having to look these up, okay, to see what the usability is for their intended use. And all the manufacturers produce something like this. Lincoln Electric has some great literature on their stainless rods or low alloy rods and how and where they can be used. So check with your supervisor when you are unsure which electrode is an AWS classification you should use. And for the most part on your carbon rods, 6010, 718, we can teach you how to read those. On your stainless, you're going to be looking those up. Ferritic, we talked about there's 3 stainless steels, right? You have martinistic, austenitic, and ferritic. Ferritic stainless steels are the poorest welding stainless steels there are. So they're very difficult, hard to master. We talked about austenitic not pulling a magnet, so it's a non-ferrous type. The second bullet here says clean stainless steel pipe before welding with a stainless steel wire brush. And why can't you use a carbon brush on stainless? Well, because you'll infect that stainless with the carbon and you'll end up rusting it out. And if you buy a stainless steel wire brush and then use it on a carbon pipe for a day and then come back, you've contaminated that stainless steel wire brush, and it's going to, again, cause your stainless steel job to rust out on you. So yes, clean a stainless steel and clean aluminum with a stainless steel wire brush. Open root V-groove welds on stainless steel plate in the 1G should not exceed plate temperature of 350 degrees. Remember how we talked about carbide precipitation and maintaining the interpass temperature. This is helping you out here. So the 350, you want to stay below that so we don't turn this, in this case, plate black and allow that carbide precipitation to take place. Backing strips on your stainless steel plate coupons are inch by 6, so they're inch wide like any other backing strip. They're only 6 inches long because on your stainless stick requirement for NCCER, your straps are only 5 inches long, so you still get an inch to play with on each end for that backer strip. Open root welds on stainless steel plate have a bevel angle of 30 degrees, which is the bevel angle that everything is done on plate at KWI. After root and before the fill, inspect the face of the weld for excess buildup. And that excess buildup will hide the trapped slag. So you want to make sure, yes, you'll probably be grinding that out a little bit to clean that. Tying in that undercut and finding those wagon tracks, digging out that trapped slag. And believe it or not, stainless steel electrodes are bad about trapping slag. Open root V-groove welds should have a root reinforcement of flush to 1/8. Same way with our cap, 1/8 is the max on that. So root reinforcement flush to 1/8 and the face reinforcement. I would say a little more than flush, but flush to 1/8. 1G V groove open root drag angle of 10 to 15. And look at that, 10 to 15 shines through. That's what all our drag angles were on our carbon rods on our plate, 10 to 15 degrees. When welding stainless steel in the 2G, for passes 4 and 7, they are the same. And this is just pulling out the fact that you really only have 3 different angles that you're working with. All right, so you've got either pointing straight in, bisecting that. You've got 20 degrees above that, pointing down, and 20 degrees below that, pointing up. So it's saying that the 4 and 7, look at that, are the same angle. So they could reword this entire thing and say the 3 and 5 are the same angle, or 1, 2, and 6 are the same angle. Yes, just understand that you only have 3 angles when you're doing stringers and you're tying into your toes. There's only 3 angles you're working with. It's just when and where you're doing those. Root pass on thin materials in the vertical position is done downhill with a very short arc length. So I would compare this to MIG. If I'm going to run a root real quick on a MIG, I'm going to run it downhill, then I'm going to go uphill over top of that. They're stressing the thin material because if you try to go uphill progression typically is a little slower, and you're going to end up blowing through that. So on thin material especially, run you a downhill root first to sort of give you a buffer. Then you can start filling and capping on the uphill progression. To fuse the weld, when performing 4G open root V-groove welds on plate, adjust the electrode work angle. And they're just talking about tie-ins. So that the word fuse they're saying right there is tie-in. So yes, we are changing that work angle to tie into the previous weld's toe, giving half our weld onto the old and then half our weld onto the base metal, causing that to tie in or fuse with both the previous weld and the base metal. And who is this joker, right? He just tacked his dang test up to the freaking structural support beam of this building. I love this picture. This is wild. Bevel angle of pipe on stainless steel, 30 to 37.5. So we're going to use 30 for plate, 37.5 for pipe. So your track torches will be set up on 30. Your bevelers for your pipe on your saddle cutters will be set up to 37.5. All right, 2, 5, 6G pipe welds start at the bottom and progress upward, and that's not going to be 2, as your 2 doesn't start at the bottom. It's a round, but your 5 and 6G especially will start at the bottom and progress up. So we start at 6 o'clock and go uphill. Start at 6 o'clock and go uphill. All right, so you don't want to be running any downhill beads with the stainless stick rods. And these are just the quadrants where we pull your test coupons for your pipe. Root reinforcement inside pipe, flush to 1/8. If I'm not mistaken, we've already mentioned that a couple slides back, but nonetheless, so the R up here stands for root, and so you have, reinforcement. You have root reinforcement and face reinforcement, and so those can be flush to 1/8, but they need to break down that wall. Don't want to be overlapped, don't want to be undercut, don't want to be excessive, don't want to be underfill. This is a pretty picture right here. That's where you want to be. Stainless steel pipe 6G root passes, electrode size best at 332. So they're recommending the thin diameter rod for your root pass, especially on your 6G pipe weld. And this is the 6GR, right? You get the restriction ring on there, 1/2 inch away from the bevel. It's causing a little bit of in your face there. You can't quite see what you're doing. We got to twist your head around a little bit there, and again, you're fighting the position you like to hold your hand in too, because that plate's sticking out and in your way. But this is where you want to be. You want to test this at KWI, the 6GR, so those weld tests out on the road are pretty easy without that restriction ring. And that wraps us up, closes us out. That is welding level 3 for NCCR. That was module 6. Shield metal arc welding, stainless steel groove welds. Good luck on your written assessment and your performance profiles out in the shop.